Okay, so we're moving on to 2.2 now. So we are going to start solving some equations, which of course you should be fairly good at because we've done them in other classes. We're going to be solving, first of all, a linear equation that will contain one variable. So here's an example of a linear equation with one variable, that variable being x. A, B, and C are real numbers. That's what that means. We already know what real numbers are. And of course, A can't equal 0, because if you think about it, if A was equal to 0, our variable x would disappear and we would have nothing to solve for. So an example of a linear equation in one variable might be 2x minus 8 equals 20. There's an example, and we are going to be able to solve that equation. Okay, so here's what the addition property of equality says. If A, B, and C are real numbers, and we know that A is equal to B, then we know that A plus C is equal to B plus C. In English, what that means, and this is a strategy that we use all the time to solve equations, is that I can take and I can add the same thing to both sides of an equation. You remember from other classes, solving equations 101. What you do to one side of the equal side, you always have to do to the other. And we can add the same thing to both sides of the equal sign. That's what this property is saying. You also know that we can subtract the same thing as long as we do it to both sides of the equation. We could multiply both sides of the equal sign by the same number. We can divide both sides of the equal sign by the same number. So even though this is only the addition property, hopefully you remember that it actually also goes with all of our basic 4 operations: addition, subtraction, multiplication, and division. So we're going to start solving these equations, and hopefully you remember that when you solve an equation, you're going to have to show me every step. So the basic idea behind solving an equation is you want to isolate the variable. You want to get the variable alone on one side. So what that means is you want to undo what's happening to the variable. And in this case, in 1a, what's happening to the x? The 5 is being subtracted from it. To undo subtracting 5, what we're going to do is we are going to add 5. And of course, when we add it to the left-hand side of the equal sign, we also have to add it to the right-hand side of the equal sign. Because now look to see what happens here. Upstairs here, we have a -5. Here we have a +5. That's going to give me a 0, so those drop out. And we end up with simply x on the left-hand side of the equal sign. And on the right-hand side of the equal sign, we have -2 plus 5, which is +3. And we have solved that equation. Let's go on to B. All right, so for this linear equation, again, we want to isolate the variable. So we want to undo what's happening to the variable. You can see right now what's happening to the y. Well, we have 1.7 that's being added. To undo adding 1.7, we want to do the opposite of adding, which is we want to subtract 1.7. And again, when we subtract 1.7, we have to go ahead and we have to do that to both sides of the equal sign. So let's see what happens. Here we have a +1.7 and a -1.7. Those are going to drop out. And on the left-hand side of the equal sign, we have y. Now, on the right-hand side of the equal sign, we have 0.3, and we're going to subtract from it 1.7. So pick up your calculators and go ahead and do the math. And you can see that you're going to get -1.4. Now, although I'm not going to make you check every equation, I want to quickly review how to check an equation because you are absolutely more than happy to do that. So remember to check an equation. In other words, to make sure that you have the right solution. You take the solution that you have. In this case, it's y equals -1.4. You go up into the original equation and you replace the y with the -1.4. And what you want to do is you want to combine the negative 1.4 and the 1.7, because remember, if this equation checks, it means it turns out that the left-hand side of the equal sign and the right-hand side of the equal sign are going to match. So in your calculator, you would take negative 1.4 and you would add 1.7. And if you do that, you can see that you get 0.3, which is the same thing as what you had on the right-hand side of the equal sign, so your solution checks. You can always check your solutions for an equation. So going on to C, you can see that there's some cleaning up that we can do on both sides of my equal sign. If you look at the left-hand side of the equal sign, remember we just did combining like terms. Do you notice that 10w and negative 4w are like terms? And we can go ahead and we can combine those. And when we do that, we are going to get 6w. There's also some simplification we can do on the right-hand side of the equal sign. We have a negative 2w and we have a positive 7w. If I combine those as like terms, I'm going to get 5w. So now, unlike our previous two examples, notice that we have variables on both sides of my equal sign. So what I want to do is I want to get all my variables to either side of the equal sign. I'll usually choose the left-hand side. So if I'm going to go ahead and do this, if I want all my variables on the left, that means I don't want this positive 5w on the right-hand side. Well, how do I get rid of a positive 5w? I'm going to do the opposite, or I'm going to subtract 5w from both sides of my equal sign. Notice when I do that, because it makes it a little easier, I'm going to line up my like terms. So on the left-hand side of my equal sign, I end up with 6w minus 5w. That's just w. I still have the plus 3 is equal to, on the right-hand side of my equal sign, the 5w and the negative 5w give me 0, so that cancels out, and we have just the positive 3. So notice all my variables are on the left-hand side, so now I want to get that variable alone. So I want to undo what's being done to it. Well, what's happening? Right now we have the addition of 3 happening to it, so I'm going to do the opposite of adding 3, which is subtract 3, and I need to do that from both sides of the equal sign. So left on the left-hand side, I'm going to have a w because those will cancel. What happens on the right-hand side of the equal sign? What's 3 minus 3? Well, that's going to give me 0. So my solution to my equation is w equals 0. So for that one, we had to do some combining of like terms and some moving things around to make the solving a little bit more complicated. D, we're going to have to go one more step. Notice what we have in D that we didn't have in any of our previous examples. We have not one, but 2 sets of parentheses. So we need to go ahead and we need to use our distributive property. And we're going to have to do that twice. So there's some simplifying we can do on this right-hand side of the equal sign. Let's go ahead and let's do it. So you can see that we're going to have a 3, and it's going to be distributed into this first set of parentheses. So 3 times 2x is 6x, and 3 times negative 5 is negative 15. Now remembering that this negative means there's really a negative 1 outside that set of parentheses, let's go ahead and let's distribute that through. So negative 1 times 5x is going to be negative 5x. And negative 1 times positive 1 is going to be negative 1. So we've eliminated the parentheses. Very important. The next thing that we're going to do, just like we did in letter C, is we're going to combine our like terms. So if we were to go ahead and combine 6x and negative 5x, you can see that we're going to have 1x. And then combining the negative 15 and the negative 1, that's going to give me negative 16. So again, we want to isolate the variable. Notice now we only have variables on the right-hand side of the equal sign, so all our variables are to the same side. But now I need to get that x alone. What's happening right now? 16 is being subtracted. So we're going to go ahead and we're going to do the opposite, and we're going to add 16 to both sides. So negative 3 plus 16 is positive 13. And on the right-hand side of our equal sign, we're left with just an x, because the negative 16 and the positive 16, when added together, give me a 0, and they cancel out. So notice what we've done there in all of those equations. Really, we've simply, when we talked about a property of equality for the equation, we've either added something to both sides or we have subtracted something from both sides. But when we looked at that that addition property, I told you it actually works for all 4 operations. So here they actually introduce the multiplication property of equality. All that means is you can take an equation and you can multiply both sides of the equal sign by the same value. In this case, we're multiplying both sides of the equal sign by c. You can also translate that to division. We can take an equation and we can divide both sides by the same number. So that gives us all 4 properties. Let's go ahead and let's solve these 4 equations. So here we go. Again, the same principle. We want to isolate the x. We want to get the x alone on one side of the equation. So we want to undo what's happening to it. Well, right now, what's happening with the x is it's being multiplied by 3/7. So what is the opposite of multiplying by 3/7? We're going to divide both sides of my equal sign by 3/7. Now, when you divide, these are going to cancel out. And remember, when you divide anything by itself, you simply get a 1. So this side becomes a 1x, or just x. Now, we need to do 9 divided by 3/7. Let's use some scrap over here. That's 9 divided by 3/7. Remember our basic arithmetic. How do you divide fractions? Well, you flip the fraction after the division symbol. So this is going to become 9, and you multiply times 7/3. If I put a 1 under the 9, you can see that the 3 cancels into the 9. So 3 divides into 3 once, and 9 divides by 3 times. So now, since I have just 1s in the denominators, we have 7 times 3. My final answer is going to be 27. Oops, 7 times 3 is 21. Let's try that again. All right, let's go on to B. Again, we need to isolate the variable. Well, what's happening right now? That variable is being multiplied by 7. So we're going to do the opposite of multiplying by 7, which is dividing both sides of my equal sign by 7. The 7s will cancel out on the left, and we're going to get x is equal to negative 42 divided by 7 is negative 6. Let's move on to C. Again, isolate the variable. What's happening to it right now? Well, what's happening to it, it's being divided by 4. How do I undo dividing by 4? I'm going to multiply both sides of my equal sign by 4. Well, let's see what happens on the left. If I put a 1 under the 4, the 4's will cancel, and just as I hoped, I end up with simply an x is equal to, and then 17 times 4 is 68. This one's going to take a little bit more work. As you can see, we've got some like terms that we're going to have to go ahead and combine. I have it on both sides, so if I have here negative 7x plus 2x, I can combine those as like terms, and I'm going to get negative 5x. If you look on the right-hand side of the equal sign, we can combine the negative 3 with the positive 20 and the negative 5. So I'm simply going to have the x Now over here, negative 3 plus 20 is 17, and 17 minus 5 is a positive 12. So we have variables on both sides of the equal sign. Remember, we need to gather them all to one side. So in other words, if I want my variables on the left-hand side of the equal sign, I need to get rid of this positive x. How do I get rid of that positive x? I'm going to subtract x from both sides of my equal sign. Negative 5x and negative x is negative 6x. On the right-hand side, the x's are going to cancel, and you're going to be left with a positive 12. We still have to figure out isolating the variable. Well, what's happening right now? It's being multiplied by negative 6. So I'm going to go ahead and I'm going to divide both sides of my equal sign by negative 6. These negative 6 will cancel, and I'm going to be left with x on the left, and 12 divided by negative 6 is negative 2. And that's my solution.